Hey everyone, I'm playing Kerbal Space Program today, and what I'm trying to do is to send a vehicle that I've created, a pretty heavy vehicle, out of the Kerbin orbit by using the gravitational pull of the moon to help slingshot it out. And so the trick I'm trying to do here is get it as close as possible to the moon so that I can use all of its gravity to then launch myself out. Eventually I want to get to Duna, which is the Kerbin equivalent of Mars. But I was thinking if I'm going to try and get out, might as well try and go for something really, really crazy, get as close as I can to the moon. There's no atmosphere to worry about, so there's nothing that's going to be slowing me down. I can essentially get a few feet above the surface. So I went in thinking that this is going to be fine. I'm going to have a nice 4 kilometer gap between me and the surface. But you'll see that this isn't quite what I expected. So I've come up really close to the atmosphere. I just want to get a good view uh, as I'm making my pass. I don't really need to do this. I could have just teleported through, but I thought, you know what? It's going to be fun. Let's just see how close we actually get what 4 kilometers looks like. Uh, what I forgot to realize is that the calculated altitude is more like a sea level kind of altitude. So you can see here that the altitude based on terrain is actually quite a bit less than the 4 kilometers. In fact, I'm looking at this, I'm seeing like it's getting kind of close. I'm getting inside 1,000 meters, getting up and down, but this looks like it's gonna be a little bit tight. Might be kissing the surface here. Oh, okay. Seems okay, but I'm looking ahead and see I'm still approaching the periapsis. That's the lowest point of altitude. And this ridge is coming up and it's going to look a little tight. Okay, okay. That's fine. I'm actually past the periapsis, so I should be starting to ascend a little bit. My altitude should start to go up. Uh, but that hill up ahead does not look friendly. And I'm thinking, I don't know if I'm going to make it. But here we go. Oh, that was really close. I'm going to say that's really, really close. Probably the closest encounter I've had. So, after accomplishing this near death pass, I decided since I actually had a save point right before all of this, uh, I was wise enough to at least make a save right before this close pass. I mean, that partly because I was just thinking about how cool it would be if I could actually pull it off. Maybe there'd be something different, wonky with the calculation or something like that. But I decided to go back to the save because what I wanted to do was just test a little bit, for science, to see what the variables were that could have made this go completely wrong. I feel like I kind of got lucky with this pass because it was pretty close. So I want to see, like, okay, what if I just have the orientation of the ship? Maybe it's upright instead of facing forward, like an arrow. Maybe if it's something like I don't know, like a brake or something. So I'm going to go ahead and fast forward to what that first experiment is, the standing tall pass. So now you can see the ship is just about to reach its perfect height as I come to approach this. And I mean, it looks about the same as the other one, but just the way that the camera is angled, I still feel like it's closer. So here comes the first test, which is that first ridge. It's not the toughest ridge, but it still looks like this might not work out so well. Whoa, that looked pretty close. So one of the things that I don't know about this is where the point. Whoa, that was close too. Where the point is that the altitude is calculating from and how tall my vessel is. So far, so good. But that last ridge is kind of where the money is. That's the closest one, the closest approach here. So gonna let that come up here. Okay, this is for all the money. Oh, it looks so close. I don't know how close that actually was, but it felt really, really close. Okay, so if the size is not a problem, what if I gave it just a tiny, tiny bit of thrust to see what kind of difference it would have on it? So here I'm just going to use my main thrusters for just a bit to see what kind of impact that would have. It turns out that that kind of thrust has a pretty big impact. Like, as you can see, this approach is nothing like what we were doing before. It's going a lot faster, and the trajectory is not going to work out. I thought maybe it'd be just a slight difference or something like that, but this is not slightly different. All right, so if thrust is too much, there's an alternative, which is to use something called the RCS thrusters. Normally, those are just for docking and rotating your craft, but I thought maybe I'll just give it a little bit of thrust, just a tiny bit, just a poof, and we'll see what that ends up changing. It looks a lot like what we were doing before. However, whereas that other run, it looked really close, this looks even closer, and we'll see. Nope, don't think it's gonna work. Nope, did not work. With that one being so close, I decided to try, okay, a little bit of thrust just like that one, but a little bit further away from the Kerbin orbit. So just a tap, and then we'll see what happens. Okay, so now it looks just like before. It looks like it's going to be the same result. Going to be too close. Whoa! Haha! It worked. We went over that ridge. These are so close. So it seems to be going fine. We'll see if it makes this next ridge. Oh man, that was so close. Now the final test. The last time that we did this successfully, it was about 90 meters. So we'll see what happens. Nope. Well, it was really close, but that was the difference, that tiny bit of thrust. I ended up doing a bunch of experiments that I'm not going to show here, but I tried things like going even further out from the Kerbin orbit and using a little bit of thrust, and I tried doing a course correction while in between the first, second, and then between that and the third ridge. But they all kind of met with the same result, which is a big fireball. One of these attempts, though, had a little bit of a different result. So one thing to know about Kerbal Space Program is every part is simulated. So if you have an explosion, that means that every single part has to break away and explode on its own based on its own tolerances. So what you get sometimes is something like an explosion that leaves your crew still safe. The opposite can happen, but in this case, the crew pod is safe. However, I disabled control of the pod because I wanted to execute that somewhere else on the ship. I needed to quickly reactivate my control because there's one layer, which is the heat shield on the bottom, and if I can collide with the heat shield, the crew might survive. So what ends up happening here, not only does the crew survive this crash, but they actually escape orbit of the moon. I think I'll end it here to say that these Kerbals, they are safe from immediate death. They only have to wait for the inevitable rescue, or perhaps because science waits for no one, that point in time where I just terminate the mission and kill all the crew on board. So, thanks for watching.